All right, this is Unit 4, Lesson 1. We are starting today with more factoring strategies. Just keep factoring. All right, so no matter what you're factoring, I hope you realize now that no matter what, you should always just check for a common factor first. There's so many times when that makes your additional factoring easier. There's plenty of times when that's all you can do. You should always look for the greatest common factor. So for these ones, we're just going to factor out the greatest common factor, and then we'll continue on with some other types of factoring. So 7x squared minus 28x, as you look at those two terms, you're thinking about what do they have in common. Hopefully you notice, oh, that was weird, that the 28 is 7 times 4, and so what these two have in common is a factor of 7. If we factor 7 out of the first term, that leaves a 7x squared, and if we factor out a 7 from that second term, it leaves a minus 4. So the common factor was 7. Essentially, when you're factoring, remember that you're unmultiplying. We want to unmultiply that 7 from those two terms. We could factor that one a little bit more, but we'll save that for a minute. In the second position, or the second example here, if we're thinking about what do these two terms have in common, we have a 2x to the third minus a 9x squared. Well, 2 and 9 don't have any numerical factors in common, but both of those terms in that expression have an x squared in common. So if we factor out those two factors of x in that first position, it's still going to have a coefficient 2 and just one factor of x remaining. And in that second term, we have just the number 9. Both factors of x came out. So we have x squared times the quantity 2x minus 9. So in that first one, our GCF was a number. In the second one, our GCF was a variable. Sometimes your GCF has both a number and a variable. So in this case, if we look at 5x squared minus 35x, you might notice that both 5 and 35 have a factor of 5, and additionally, both of those terms have a factor of x. If we factor out that 5x from the first term, the only thing left is one factor of x, and in the second term, we have the number 7. 5x times the quantity x minus 7. GCFs don't just apply to binomials. Trinomials can have a GCF. Polynomials with 4 terms can have a GCF. Any number of terms is fine. You should always still just scan it and look for a GCF. In this one, we have an 8x to the third minus 40x squared minus 16x. So definitely all of those terms have a factor of x, and additionally, they are all having a factor of 8. So we can factor out an 8x here. If we do that, we have in that first term just 2 factors of x remaining. In the second term, if we factor out an 8 from 40, that leaves a 5. And we also have 1 factor of x that's remaining. And in the last term, if we factor out an 8x from a 16x, it would be a minus 2 in that last term. So we have 8x times the trinomial x squared minus 5x minus 2. Last one of these, what do 3x to the third, 27x squared, negative 3x, and negative 27 all have in common? Well, hopefully you identified that they all have a 3 in common. This last term does not have an x, so we are not able to factor out a variable from this expression. If we factor out a 3 in this first term, that will leave behind those 3 factors of x, x to the third. If we factor a 3 from the 27x squared, we're left with a 9x squared. If we factor out a 3 from a negative 3x, we just have negative x, or negative 1x if you like. And this last term would be a minus 9. Okay, so every problem, every time, it's just a quick mental scan. Does it have a GCF? If so, factor it out. If not, you move to your next strategy. Okay, so now that we've just refreshed on GCFs, we're going to go through some binomials, some trinomials, and today even some polynomials with 4 terms like this one, and we're going to be factoring those. Let's start with binomials, 2 terms. If you have 2 terms, the first thing you want to look for is, does it have a GCF? And this first one, hopefully you notice that yes, it does have a GCF. 98x squared minus 8 has a factor of 2 in common. And if you don't see that right away, I would probably start by testing 98 and seeing if 8 is a factor. If 8's not a factor, which it's not, test 4 and see if 4 goes into 98, which it doesn't. So if 4 didn't go in and 8 didn't go in, maybe 2 does. 2 is a factor of 98. If we factor a 2 out, what we have is a 49 x squared minus, and in the second term, if we factor out a 2, we would have a 4. All right, so we have our GCF factored out. We've got these 2 terms. So last unit, we talked about our special patterns. If you have a binomial, if you have 2 terms, you can always check and see if it fits one of our special patterns. Our special patterns are difference of squares, which factors as a plus b times a minus b, and you have these on your paper. Sum of squares, which factors as a plus bi and a minus bi. And we have a sum of cubes and difference of cubes. So this would factor as an a plus b, a squared minus ab plus b squared. This one factors as a minus b, a squared plus ab plus b squared. So we factored out our GCF. We're looking at this problem. We have a 49x squared. We have 49, which is a perfect square. We have 4, which is a perfect square. This is definitely a squares pattern, and it's a difference of squares. So when you factor a difference of squares, that's this top one. It factors as an a plus b and an a minus b. So in this case, it would be a 7x plus 2 and a 7x minus 2. And most of you are really good at recognizing those. So that's our complete factorization. All right, this next one down, 14x squared plus 35x. You know, you see that x squared, maybe you're thinking maybe this is a perfect square one too, but 14 is not a perfect square. 35 is not a perfect square, and we've got this extra x over here. So what you really should start with, and you should start with it every time, is does this expression have a GCF? Is there a common factor? Well, 14 and 35 both have a 7 in common, and both of these terms have an x. So we're going to factor out the monomial 7x. If we factor out a 7x, in this first term it's going to leave behind a factor of 2 and 1 factor of x. And in the second term it's going to leave a factor of 5. 7x times 5 is 35x. So it actually looks like once we recognize that we had a GCF, that's our complete factorization. There's nothing else we can do. So check for a GCF. Don't assume that it's a pattern because you see a certain power. Check for a GCF. All right, this next one, 64x to the 4th plus x. Again, the first thing you should do every single time, no matter what, is check for a common factor. 64x to the 4th plus x. The only thing these 2 terms have in common is that they both have a factor of x. If we factor that out in the first term, we have 64x to the 3rd, and in the second term, and there is a second term, we're factoring an x out of 1x. Write that 1 if it helps you to remember that this is going to be a plus 1 right here. Okay, so we've got 64x to the 3rd plus 1. We have a 3rd power of x. We have a 64, which is the same as 4 to the third power. We have a 1, which is the same as 1 to a third power. This is going to be one of our cubic patterns. In this case, it's going to be this one right here at the top of my screen right now. So this 64 is a 4 to the third power. So when we factor it, it is going to be a 4x here plus 1. Now our pattern tells us that this next term right here, the beginning of the trinomial factor, is going to be an a squared. So sometimes people make the mistake of saying, okay, this is 4x squared. But what you're forgetting is that the 4 is also squared. But even if you think of it this way, these two together are 16x to the third. But the thing I'm trying to factor is a 64x to the third in that first term. So that didn't get me where I wanted to be. So make sure, double check things as you're going. This first term is the number 4x all squared. So it's a 16x squared. Then we subtract a times b, so that's a 4x, and then we add b squared. Well, that's just going to be a 1 squared, which is just 1. So this is our complete factorization of 64x to the fourth plus 1. Or 1x, sorry, I have writing all over it. Remember that this first factor does not disappear, this x. That is one of the factors of that expression. Don't lose it, please. Okay, let's try another one. Let's shift these down a little. 9x to the third plus 121x. So please remember, every time you factor anything, whether it's a binomial or trinomial, look for a GCF first. This expression, both terms has a factor of x, which we can factor out. So factor out the x, you have a 9x squared plus 121. This is a second power. 9 is 3 squared. 121 is 11 squared. This is going to be a square pattern. It's up at the top lost, but remember, if we have a sum of squares, if it's a plus in between those two, it factors as a plus bi and a minus bi. So if we keep factoring this, it's going to be a 3x plus 11i and a 3x minus 11i. That is our complete factorization of 9x to the third plus 121x. Last one of these binomials. We have an x to the third minus 343. You should always check and see, is there a common factor? In this case, the answer is no, they don't have a common factor. But we have a third power here. We have a 343, which is 7 to the third power, if you want to think of it that way. And you should think of it that way, because then when you go to factor it, you'll not make any errors. This is a difference of cubes, which you have on your paper. I'll just rewrite it right here. Whoops, b squared. Okay, so our a is x, our b is 7. So the a plus b, that first term is going to be, or sorry, that first factor is going to be an x minus 7. The second one, it's got to have an x squared, because together we need an x to the third power. The pattern tells me now I have an a times a b, that's a 7x. And then the last term is going to be b squared, which is 7 squared, for a 49. So here's our complete factorization. If you think you might have made an error, multiply a bit of it out. See if this is giving you that first term. See if this is giving you that last term. You can multiply the whole thing out. In this case, there'll be a lot of cancellations. Test it out. See if it works, if you're not sure. So that is the binomial section of today. So these all were binomials, lots of different cases here. Check for a GCF first and then see what you have. See if you have perfect cubes or perfect squares and then maybe use one of those patterns if it applies. All right, let's go to some trinomials. These first two are nothing new. This is the same as what we worked on last time. We're just going to practice it some more today, and then we'll look at a couple that are new. So remember, if you have a trinomial, what you're trying to do is factor it into two binomials. And these first two terms here have to multiply to give us that 10x squared. So I think it's pretty likely that we're going to have a 5x and a 2x. Those two together give me that 10x squared. Now it's also possible, and we may need to check it in a minute, it's possible that it's just a 10x and an x. So if we are not having luck with the 5x and the 2x, we can switch to the 10x and the 1x. But let's try the 5x and the 2x first. Now the ending two terms have to multiply to give us -6. So it's some combination of 3 and 2 or 6 and 1. And we can play with the signs a little bit in a minute to see if we can get the right combination. But it's either going to be a 3 and a 2 or a 6 and a 1. So let's just try something. Let's try a 3 and a 2. Well, to be honest, I probably wouldn't put the 2 here because of this other 2. So let's, and it's good to kind of pay attention to things like that because they can give you clues as you're doing it. So let's start by putting the 3 here and the 2 here. So that's giving me the 6. The 5x and the 2x combine to give the 10x squared. What we need to test now that we have this set up is, can we get a -11x out of this? Well, here's a 15x, and here is a 4x. So the question is, could that combine somehow to give me a -11? And hopefully you notice that, yeah, it can, if this is a -15. So if our 15 is negative and our 4 is positive, we have that combination of -11x, and we have found the two factors. Now you don't always find them on the first try, but sometimes you do, and if you don't find them on the first try, you just try something else, like that 10x and the 1x. All right, let's try another one. So we've got 12x to the third minus 25x squared plus 12x. And remember, the first thing you should always do is check to see if there's a common factor you can factor out. And in this case, there is a common factor of x. If we factor it out, we have 12x squared minus 25x plus 12. All right, so we've got this trinomial here. We're going to hopefully be able to factor that into two binomials. Well, remember that these two leading terms are going to have to combine to give us a 12x squared. So it could be that it's a 4x and a 3x. It could be, in a minute, we may need to try 6x and 2x, or it could even be a 12x and an x. It's got to be one of those combinations. So let's start with the 4 and the 3. For the end of each of those factors, those have to combine or multiply to give us that 12. So it could be, again, a 3 and a 4, it could be a 6 and a 2, could be a 12 and a 1. Let's try the 6 and the 2 first. Maybe the 6 goes here and the 2 goes here. Well, that gives me an 18x and an 8x. Even if they're both negative, that's going to be a 26x, which is not what we wanted. We wanted a -25. So that combination didn't work, and it's okay. If it didn't work, try something else. Either switch the 2 and the 3, or change to a different set of numbers. Let's switch to the 3 and the 4. So if I switch to the 3 and the 4, well, this one already has a 4 leading it, so let's put the 3 there and the 4 there. And let's try that and see if it helps. Erase these arrows for a second. So this gives us a 9x and a 16x. Could that add up to negative 25? Well, I hope you notice it could if they're both negative. So we need both of these factors to have a minus sign, and we have come up with our complete factorization. Now, if we still hadn't found a correct factorization, we would maybe just switch to trying this combination, and maybe that would give us the right combination of terms to give us this trinomial that we started with. But we already found it, so we're good. We don't have to keep checking anything else. All right, still 3 terms, still trinomials, but now we have some higher powers. Is that okay? Well, I don't know. Let's just try it and see. So our leading term here is x to the 4th. Well, it could be that it's this, or it could be that it's an x squared times an x squared. Since I'm seeing an x squared here, I am thinking if we put x squareds here, that might help us. Remember that these two parts, these two ending parts of the factor, come from this 42. So let's think about 42 for a minute. Probably the one that comes to mind first is 6 times 7. Another one is 3 times 14. Another one is 2 times 21. And then, of course, 1 times 42. So, maybe you start with the 6 and the 7. And you think about what that would give you for your middle. That would be a 7x squared and a 6x squared. Well, that gives me a 13x squared. So it's close to 17, but not quite. So we've got to try something else. Maybe we try that next one down, 3 and 14. Well, if we try that, what we have here is a 3x squared and a 14x squared, which certainly could add up to 17x squared. They both need to be positive. This is our complete factorization. Now, if you have those x squareds in your binomial, it does pay to pause for a minute and think about if you can factor one of those a little bit more, but neither 3 nor 14 are perfect squares, so that is finished factoring. All right, let's try another one of those. 2x to the 4th minus 12x squared minus 54. Always pause and check to see if you could factor out a GCF. In this case, we can factor out a 2. So that leaves x to the 4th minus 6x squared minus 27. Okay, so let's see if we can factor this trinomial a little bit more. We still have a factor of 2 at the beginning there. Well, we've got x to the 4th. Let's try x squared and x squared. At the other end, we have a 27. That's either a 9 times 3 or a 1 times 27. So in this case, it looks like maybe we should try the 9 and the 3. And to get a, let's see, we have a 9x squared and we have a 3x squared. We're trying to get a negative 6x squared, so if that 9 is negative and the 3 is positive, we should be good. So we've got some nice combinations here for our binomials, but you might have noticed, dun dun dun, that this is also factorable. We can factor that a little bit more. So we still have a 2. We can factor that that x squared minus 9 into a couple of factors, and we'll still have an x squared plus 3. There's not much I can do with that. But x squared minus 9 factors as an x plus 3 and an x minus 3. So look for those cases where you may be able to factor a teeny bit more. So all in all, we have 4 factors there. We have 2, we have x plus 3, we have x minus 3, and we have x squared plus 3. All right, let's solve this for x. So we're going to use factoring as a method of solving, but we're still just factoring to solve this equation. So we have 3x to the 5th plus 9x to the 3rd minus 12x. Hopefully by now it is completely ingrained into your brain that you should check for a common factor first. And hopefully you see that the common factor here is a 3 and an x. If we factor out a 3x, that leaves us with x to the 4th plus a 3x squared. We're factoring only one factor of x out, and minus a 4. Well, I think x to the 4th plus 3x minus 4 is factorable. We have an x to the 4th, so let's try it with an x squared and an x squared. And that negative 4 is probably going to be a 4 and a 1. It could be a 2 and a 2. We would maybe check that if we couldn't find this one right. But it looks like if we use a positive 4 and a negative 1, we're going to be good. So we're not done solving yet. You may have noticed at the beginning of the problem that we should have 5 solutions. So I can already see one of them is 0. That comes from this factor here. The other 4 are in these other two factors. Well, you may have noticed that both of these are perfect square patterns. This one's a plus 4, so we have x plus 2i. Remember, if this is a positive, you're going to have that imaginary part, that I, and x minus 2i. X squared minus 1 is a difference of squares, so it's going to have real factors, not imaginary, x plus 1 and x minus 1. So now hopefully you can see the other 4 solutions, negative 2i, positive 2i, negative 1, and positive 1. So there are our 5 solutions to this equation. All right, almost done. We are now going to practice factoring by grouping. So factoring by grouping is a new method for today for 4 terms. It's not the only way to factor polynomials with four terms, but for this unit, we will be limiting ourselves to this case. So we have 5x to the 3rd plus 10x squared plus 3x plus 6. So when you need to factor a polynomial with 4 terms like this, this grouping method, we think about each of these 2 groups kind of separately for a minute. And we think about the GCF of each group. Well, in this first group, we have a common factor of 5x squared. And if we factor that out, we're left with an x plus a 2. In the second group, we have a 3x and a 6. So those both have a 3 in common. That's their GCF. If we factor that 3 out, we're left with an x plus 2. Now here's where grouping comes into play. So since we thought of those groups separately, you might notice that we now have, I'm going to put a heart around it, an x plus 2 in both of our terms. We have 2 terms here, and they both have a factor of x plus 2. So what we can do is factor that x plus 2 all the way to the front. And when we do that, what's left is a 5x squared plus a 3. So those are our 2 factors. We have a 5x squared plus 3, and we have an x plus 2. Now, in some cases, you'll be able to factor it a little bit more, maybe, but in this case, we're done. So let's try a couple of those. 3x to the 4th minus 18x to the 3rd plus 4x minus 24. If we use grouping as our method, let's think about this group first. What do they have in common? Well, they have a 3 and an x to the 3rd. If I factor that out, it's going to leave an x minus a 6. For my other group over here, they have a 4 in common. If we factor that 4 out, in this first term we have an x, and in the second term we have a minus 6. So now I have 2 terms. What do those 2 terms have in common? Well, they both have this x minus 6. So let's factor that out. X minus 6, if we factor that out, this first term just has a 3x to the third, and the second term has a 4. So this would be our complete factorization. Again, sometimes you're able to factor a little bit more, but in this case we are not. That is done. Let's try another one of these. Think about those two groups. In this first group, what do they have in common? Well, it's an x squared. If we factor that out, it leaves an x plus 5. In the second group, because we're doing grouping here, they have a negative 4 in common. If we factor that out, it's an x, and we're factoring out a negative 4, so this becomes a plus 5. Hopefully you're noticing that both of those terms now have an x plus 5, which we can factor out, leaving behind an x squared minus 4. Now this is one of those cases where you might notice we can factor a little bit more. X squared minus 4 is x plus 2 and x minus 2, so we are now finished. Okay, so factor by grouping works brilliantly in all of those examples. It doesn't always work. So I just want to show you what it looks like when factor by grouping fails, when it doesn't work. So let's try this one. If we group these two terms and factor out an x squared, we have an x plus 5. And here, if we factor out a common factor, that common factor is 5, leaving behind an x plus 3. So this grouping did not work because these two factors here are not the same. So we can't factor anything out anymore. Grouping did not work. We'll show you some methods for factoring things like this next unit, but for now we would just say that we were not able to use grouping to factor that. Just one more, just so that you can see, if you didn't already. If we factor out a common factor from these two terms, that would leave an x minus 4. If we factor out a common factor here, let's see, 20 and 48 have a 4 in common. That would leave a 5x minus 12. So again, these two factors that are remaining are not the same. So we are unable to continue factor by grouping, and it did not work, okay? So one last problem. Solve for x. 4x to the third plus 49x is equal to 8x squared plus 98. First of all, this is a polynomial. We are looking for 3 solutions because that power 3. So first of all, if we're solving a polynomial, we want to make sure that we have that polynomial equal to 0. So we're going to subtract these things to the other side. Now none of those combine, so we'll have a 4x to the third, a negative 8x squared, a plus 49x, and a minus 98. I put it into standard form, putting them in order. So now we try to factor it. Well, check for a GCF, but 49 is not gonna, it's 7 times 7. So there's not a common factor here. There's not a common factor of x because the 98 doesn't have an x. So we're gonna notice now, hopefully, that you have 2 groups of 2. You have a 4-term polynomial, so let's try grouping. This first set has a 4x squared in common, leaving behind an x minus 2. In this second set, I can factor out a 49, leaving an x minus 2 when I factor it out. Grouping works great here. We have an x minus 2 and an x minus 2, which we can factor all the way to the front. So now in our first term, we have a 4x squared, and in that second term, we have a 49. Okay, so we're getting closer. Hopefully you notice that 4x squared plus 49 is a whole bunch of perfect squares. 4 is a perfect square. We have an x squared, we have a 49, which is a perfect square of 7. So we can factor this a little bit more. We still have that x minus 2. 4x squared plus 49. This is one of those plus It's a sum of perfect squares. So this is going to be a 7i and a 7i. So for our three solutions, we were looking for 3, remember. X equals 2, x equals negative 7i over 2, and the last one is a positive 7i over 2. Those are our 3 solutions to the equation. And we are done for that lesson. So a lot of what we did today is review of what we did the prior unit, just those 2 new cases where we had higher powers. Please come in if you need some help with factoring. You can do it. If you need a little help, I would love to help you so that you can master that.